something enormous has entered our solar system. It does not shine, it does not orbit the sun, and it has traveled through darkness for millions of years. This frozen planet is roughly the size of Jupiter, and it is heading toward the inner solar system. At first, nothing changes. Earth keeps spinning, and your phone alarm still ruins your morning. But this visitor does not need to hit Earth to destroy everything we know. Its gravity alone could rearrange the solar system. These nomads are rogue planets, worlds drifting through interstellar space without a host star. No star, no address, no forwarding number. They either form alone in gas clouds or get ejected from young systems, creating a cold, approximately Jupiter-sized world. Because it reflects no starlight, finding it would be like searching for a black bowling ball inside an unlit stadium, except the stadium is billions of kilometers wide. It is basically the cosmic version of someone entering your house without turning on the lights. To spot it, we must rely on infrared sensors capturing its faint internal heat, or trace it through gravitational microlensing. Its eventual path depends on mass, speed, and trajectory, with its gravitational influence tied to mass, not physical size. But Earth would not be the first thing in danger. As this dark giant enters the freezing outermost edges of our cosmic neighborhood, it first encounters the Oort cloud and the Kuiper belt. These distant, loosely bound reservoirs of ice and rock feel the massive tug of the interloper. The solar system spent billions of years arranging the furniture. This planet arrives and immediately moves the sofa. Some icy bodies are violently thrown out into deep space, while others are redirected inward. But don't expect a sudden barrage. Any resulting comet threat would take thousands or even millions of years to arrive. The comets, unfortunately, do not respect appointment times. As the rogue plunges deeper, Uranus and Neptune face extreme danger. A close pass could warp their circular orbits into highly eccentric ellipses, or tilt their entire planes of motion. In the most extreme, worst-case trajectories, one of these ice giants could even be ejected from the solar system entirely. Then, humanity finally notices what is approaching. The first reliable sign is a faint, moving object that does not match the known catalog. As it approaches, reflected sunlight becomes useful, while infrared follow-up helps characterize this enormous dark world. Using databases from JPL Horizons and NASA's Solar System Dynamics, astronomers calculate a range of possible trajectories from repeated observations. The internet would remain calm and verify every fact, which may be the least realistic part of this scenario. Someone would still claim it was an alien spaceship. The first official warning would be very hard to fit in a push notification. Because nuclear weapons could not destroy or meaningfully move a Jupiter-sized planet, realistic responses mean trajectory prediction, public coordination, food and energy planning, and building protected habitats. But before reaching Earth, the visitor meets the biggest planet in our neighborhood. In this illustrative simulation, modeled as an example, not a prediction, a rogue planet with one Jupiter mass enters the inner system at 20 kilometers per second at a 45-degree angle, passing 15 million kilometers from our largest gas giant. Even Jupiter would prefer that this visitor used the doorbell. As these two massive worlds interact, they trade orbital energy and momentum, permanently shifting their paths. Jupiter's guest list has always been aggressively exclusive. A clean, two-body flyby cannot capture the rogue. Binding it to the Sun requires a complex three-body exchange where Jupiter absorbs the traveler's kinetic energy. But Jupiter is not a perfect shield. While it might fling the interloper harmlessly into the cold void, it can also redirect the giant directly toward us, while its own shifted orbit slowly destabilizes the rest of the solar system. A non-collisional flyby, even several million kilometers away, is where orbital geometry decides our fate. The severity of the encounter isn't dictated by distance alone. The rogue's speed and direction of travel control how much energy is transferred. A distant pass at 5 million kilometers might only nudge us, but a slow, severe pass at 1 million kilometers triggers massive tidal distortions. Because gravity pulls harder on the side of Earth facing the intruder than the side facing away, our oceans would bulge violently, causing severe coastal flooding. humanity would finally agree on one thing: the new planet was lowering property values. This intense, unequal tug creates deep crustal stresses, potentially triggering conditional volcanic eruptions and earthquakes along active fault lines. Meanwhile, the moon's stable home is threatened. It could be warped into a wider, highly elliptical orbit or set on a dangerous future path, though completely losing our companion would require a nearly direct collision. The moon has never appreciated surprise renovations. If Earth survives, its path around the sun would become permanently stretched, exposing us to extreme, long-term climate swings as our distance from the sun varies. But despite popular myths, gravity does not simply switch off, and nobody is floating into space. We would remain firmly pinned to a world with a highly unpredictable future. Astronomical models suggest exactly 3 possible endings. First, the rogue planet sweeps through and escapes back into the dark. While the major planets survive, they are left with permanently warped orbits and a long-term threat of destabilized comets. Second, the sun captures the intruder into a highly eccentric, distant orbit, creating a crowded solar system that remains dynamically unstable for billions of years. Third, an extreme encounter pushes Earth into a lethal new orbit, collides directly, or ejects us entirely into interstellar space. In a direct collision, immense gravitational forces would instantly shatter our planet. If ejected, sunlight would fade to black, temperatures would collapse, and our atmosphere would eventually freeze solid. Deep-sea microbes near geothermal vents might survive, but on the positive side, traffic would no longer be a problem. A rogue planet would not need weapons, an atmosphere, or even a direct collision to change our world. Gravity would be enough. It could disturb comets, move planets, steal our moon, or push Earth away from the sun. Fortunately, the odds are incredibly small. But somewhere between the stars, countless lost worlds may be traveling alone right now. We simply hope none of them are traveling toward us. What would you do if a new planet appeared in our sky? Tell us in the comments and subscribe to Astral Nexus HQ for more scientifically grounded what-if scenarios. These invisible cosmic nomads are real. In 2011, Takahiro Sumi and his collaborators published a landmark study in Nature on unbound planetary mass populations using gravitational microlensing as a statistical way to search across enormous distances for worlds that emit little light. By observing how their gravity warps background starlight, they suggested these rogue Jupiters might be common. In 2017, Przemek Mroz published a more conservative constraint in Nature, finding no such massive population. These studies disagree on the exact abundance, but both confirm that starless worlds exist. To find them, infrared telescopes survey younger, warmer populations by capturing their faint internal glow. Fortunately, the sheer scale of interstellar space makes a dangerous encounter during a human lifetime extraordinarily unlikely. They remain a source of quiet wonder, countless lonely worlds traveling through the dark. Today, our quiet sky feels permanent, but as we map the silent dark, we realize our sanctuary isn't guaranteed. It is merely a fragile, beautiful stroke of cosmic luck.